Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to walk you guys through how to solve every problem on the probability quiz review. And it says quiz review slash mixed practice. Okay, so there are going to be some problems on here that you won't necessarily see on the quiz, but it's just overall good practice for probability. My disclaimer as always is I need you guys to work each of these problems and then and only then come to the video and see where you might have made any mistakes, or if you're not sure how the posted solutions got a certain answer, then you can come and figure out where you might have made a mistake or had a misunderstanding. Alright, so my Clemson reference today is going to be this awesome picture that my father bought me. And this is a picture of Clemson's quarterback from a few years ago who won the national championship for Clemson. His name is Deshaun Watson, and he's currently in the NFL. So here's a picture of Deshaun Watson leaping several feet in the air over the big bad Alabama defender. And at the bottom, we've got Clemson Tigers 2016 national champions. Big deal for Clemson fans. Okay, so without further ado, let's go ahead and jump right in. I'm going to need you guys to get out your calculator with me today so you know how to punch these things in and simplify your fractions. So the first one says a pizza parlor surveyed 100 customers to determine their favorite pizza topping or combination of toppings. The results are shown below. Now sometimes they don't give us the total. We have to figure that out. So I'll just simply add up all these numbers. And you got to remember, guys, each of these numbers are different people. So the 3 is not included in the 18 for the mushrooms. These are 3 different people. So, but they've already given it to us, so we've got 100 total people. All right. So the first question says, how many people like all 3 toppings? So that's basically the overlap of all 3 circles. Okay, so that's going to be this overlap right here. So we've got 5 people. Zoom in maybe a little bit more. We got 5 people who like all 3 toppings. That's pretty easy. Then it says, what is the probability of randomly choosing a person who likes pepperoni? Okay, so we're only looking at the pepperoni people. Okay, let me make sure my camera is focused. Y'all see those numbers easy. Okay, so I'm only looking at the people in the pepperoni circle. Okay, I'm actually going to do these in different colors, guys, so that we're not circling the same stuff over and over. So I want all the people who like pepperoni. Okay, these are all these people that I circled in orange. Okay, so you got to add all those up. 36 plus 7 plus 5 plus 4 gives me 52. Alright, so we got 52 out of a total of 100. Okay, 52 out of 100. Now, guys, on the quiz, I can't allow you to give me a fraction if it's not fully simplified. Okay, so 52 out of 100. Now, I know a lot of you guys are good with math and numbers. You can just do that in your head. For those of you who struggle with math and numbers is not your thing, please do this on the calculator. We've got 52 people divided by 100 people. Okay, that's going to give me some decimal, in this case 0.52 or 52% of the people like pepperoni. Okay, so 52 out of 100 is not simplified. So the first thing I need to do is type it into my calculator, get a decimal, and then I'm going to come down here and see this button right here. It says math. I'm going to press math. That's going to give me this option, and the first thing up the top is frac for fraction. Okay, I'm actually going to press enter twice. 1, 2. And there you go. My calculator simplifies the fraction for me. Guys, I'm begging you to please use your calculator. Even if you're a genius and you're good at numbers, at least use this to check and make sure that you didn't simplify it incorrectly. Because it's so frustrating when you know exactly what you're doing, but you just make a careless mistake and throw points away on a quiz or a test. So this simplifies to 13 out of 25. Okay. Now remember, I told you guys I'm okay with decimals, percentages, or fractions. Okay, but fractions have to be simplified. If you wanted to give this to me as 0.52, that's fine. If you wanted to give it to me as 52%, that's fine too. Now, when these decimals get really long and nasty, I really do want you to convert those to a fraction. Okay, if possible. All right. Next one says, what is the probability of choosing someone who likes? What's that word right there, guys? Say just sausage. Okay, probability, guys, is all about the trigger words and the key words. You must find and isolate and circle and underline these important words. I've been circling these words ever since we've been doing probability. Okay, that's a huge word. They're not asking who likes sausage, who likes just sausage. Okay, so the people that only like sausage are just these 27 people. I'm not including the 3 because these 3 people also like mushrooms. These 5 people like all 3. These 4 people, they like sausage and pepperoni. I want just the sausage, okay? So that's only 27 out of 100, okay? Now you might be asking, why don't we have up here number in letter A, why isn't this 5 out of 100? Okay, because it's asking how many people. Okay, I know reading comprehension. Some of you guys struggle with reading comprehension. You just go too fast. You don't bother to read the whole problem. How many physical people like all 3? That's 5 people. In fact, I should write that out. 5 people. Okay, but look at the next few questions. What is the probability? Okay, that's different. The probability is 13 out of 25 or 52%. Probability that you like just sausage, that's 27 out of 100. Okay. All right, I can't simplify that any further. If you're not sure if you can simplify it, put it in your calculator. 27 divided by 100. Okay, go math, fraction, enter, enter. Oh, well, guess what? I can't simplify it. It's the same thing. Okay, letter D. What is the probability of choosing a person who does not like mushrooms? Okay, I'll do this in red. So this would be like our M prime, guys, the M tick. That's our complement. Okay, so the not mushrooms. Give me everybody who does not like mushrooms. Okay, so up here in red, I'm going to circle everybody who's not in the mushroom circle. Okay, so that's going to be these 36 people, these 4 people, and those 27 people. Okay, so I add those up. 36 plus 4 plus 27, and I get 67. So I've got 67 out of 100 people. Okay, sorry. Can I simplify that? 67 divided by 100. Math, fraction, enter, enter. Nope, can't simplify that. Okay, I guess I should put boxes around these. All right. So those are the word problems. Now we have the actual set notation, with these upside down U's and the right side up U's. Guys, you're going to have to know these when you walk in the room. You can't come in here and say, oh gosh, I can't remember what that upside down U means. Look back in your notes from day 1. Okay, the right side up U. Let's just go back up here for a second. The right side up U, that's your union. That means give me everything. So if I were to ask you for SUP. Okay, that means give me everything that's in the sausage circle, everything in the pepperoni circle. Give it all to me. Okay, give me the 3, the 5, the 4, the 27, 36, and 7. Give it all of it. Okay, that's the union. When you see the upside down U, that's your intersection or your overlap. Okay, that's the key word, overlap. Okay, and then remember the tick means complement or not K. Okay, so go back and refresh your memory on that stuff. This is the upside down U. Okay, so that's the intersection, that's the overlap. I'm actually going to do these in 2 different colors. I'm going to do these in, let's see, do I have a different color? Looks like all I have is, I got black. I will do this in black and green. Okay, I'm going to circle everything in the sausage circle. Okay, so sausage will be that one, that one, that one, that one. And I'm going to circle everything in the pepperoni circle. That one, that one, that one, that one. Okay, I know that's hard to see, but basically what I'm doing is, where did I circle green and black at the same time? Where's the overlap? Well, it's going to be these 2 guys, the 5 and the 4. That is the physical overlap of the sausage circle and the pepperoni circle. That's these 2 guys right here in the middle, the 5 and the 4. Okay, so 5 plus 4 is 9. I'm going to write down overlap. 5 plus 4 is 9 out of 100. Okay, and we cannot simplify that any further. Okay, so there are the Venn diagrams. All right, let's move on. Taylor conducts an experiment with rolling a number cube. It is rolled 50 times and the results are recorded below. Okay, so guys, when you see a chart of data, maybe I need to zoom out here. When you see a chart of data, you know it's going to be experimental. Okay, so you got to find these trigger words. What is the experimental, based on the experiment of the probability of rolling a 3? Okay, so I'm looking at the data. Okay, how many times did I roll a 3? Okay, I rolled it 4 times out of a total of 50. Okay, so my probability, we would say based on the experiment, is 4 out of 50. Does that simplify? You betcha. Math, fraction, 1, 2. Bam, there it is. 2 out of 25. Let the calculator do the work, guys. Math, fraction, boom, boom. Takes you 2 seconds. All right, theoretical. Okay, when I see theoretical, guys, I don't care about the data. Don't look at the data. We're not basing it on an experiment. Theoretical means what should happen. What is supposed to happen when I roll a 6-sided number cube? What are the chances of getting a number less than 5? Okay, well, here we go. Here's a number cube. I got 1, 2, 3. What comes next? I think it's 4, isn't it? 4, 5, 6. I've got 6 different numbers. What are the chances I'm going to roll something less than a 5? Well, that's going to be your 1, your 2, your 3, and your 4. Okay, I got 4 chances. 4 chances out of a total of 6 chances to roll a number less than 5. That reduces to 2/3. Okay, here's that word, experimental. You gotta read, guys. You gotta read and find the words. What is experimental? Probability of rolling an even number. Okay, so which ones are my evens? 2, 4, and 6. Okay, so how many times did they roll a 2, 4, 6? They rolled it 12 times, plus 9 times, plus 11 times. Okay, so they got an even 12 plus 9 plus 11 over the total of 50. Okay, add those up. 12 plus 9 plus 11. Oops. I know you guys can do this in your head. I'm doing this for the benefit of those who struggle with numbers and struggle with math. Okay, so that's 32. That's 32 out of 50. Let's simplify that. 32 divided by 50. Math, enter, enter, boom, boom. 16 over 25. Okay. Theoretical. I don't care about the data. What's supposed to happen? What is the probability of rolling the number 1? Well, how many 1s do I have on a 6-sided die? I only have 1. So I only have 1 chance out of a total of 6 different numbers, 1 through 6. So that's a 1 out of 6. Okay, now when we get down to these card problems and drawing marbles out of the bag, guys, you've got to find those trigger words. Replace, without replace, and or. You're going to need your graphic organizer here, okay? If you're in and land, I put this together so you guys could see, okay, what do I do when I see the word and? What do I do when I see the word or? Okay, when you see the word and, when you're in and land, it could be 2 different things, either independent or dependent. Do the 2 things affect each other? Do the 2 things not affect each other? Okay. When it's independent, you're going to see with replacement. I put the marble back. I put the card back. Everything resets. I start over with 52 cards. I start over with 78 marbles. Okay. If you put it back, the denominator doesn't change. Okay. I draw a jack, I put it back in the deck. I draw another king, I still have 52 cards. The denominator doesn't change. But in either case, when you see the word and, guys, in either case, I'm going to multiply the probabilities. If it's dependent, you're going to see the words without replacement or doesn't replace. Then the denominator is going to decrease by 1. If you're pulling 1 card, if you're pulling 1 marble, then the number of marbles left is going to go down by 1. The number of cards left is going to go down by 1. But I still multiply. Okay. If you see the word or, that's either exclusive or inclusive. Okay, do the 2 things have anything to do with each other? Can they happen at the same time? No. If they're isolated, they can't happen at the same time. There's no overlap. You're going to just simply add the probabilities. If the 2 things can happen at the same time and you see the word or, that's inclusive. That means there is some overlap. What are the chances of getting a spade and a 7? Well, I can be a 7 and a spade at the same time. That's the 7 of spades. You have to add the probabilities and then subtract out the overlap. Okay, so study this graphic organizer. Okay, so here are the marbles. 75 marbles, 8 white, 10 red, 20 green. The remaining marbles are clear. Okay, what is the chance of picking a clear marble? Well, where are the clear ones? We got 8 white, 10 red, 20 greens. Where are the clear ones? We got to figure that out. Okay, well, there's 75 total, and the rest of them are clear. So the clear is going to be equal to total minus the red, white, and green. I don't know why they didn't make it red, white, and blue. Come on, man. Come on. 70 minus 8 plus 10 plus... I hallucinated. I know you guys are yelling at the screen. I rigged out there for a second. minus 10 minus 20. 70 minus 8 minus 10 minus 20. That leaves me 32 clear marbles. Okay. Oh my gosh. Oh my gosh, guys. I'm sorry. I'm hallucinating. I'm literally hallucinating. That's awesome. Okay, sorry. This is why you need to check your work, okay? 75 marbles minus 8 minus 10 minus 20 gives me 37 clear marbles, okay? All right, so the probability of choosing a clear marble is going to be 37 out of the total 75 marbles, okay? 37 out of 75. Does that reduce? 37 out of 75. Math, enter. Nope, doesn't reduce. Okay, so 37 out of 75 is the answer. Okay, suppose a family has 3 children, each 2 years apart from one another. What is the probability that the family has 3 girls? Okay, what are the chances that I get girl, girl, girl? We're going to have 3 children. Girl, girl, girl. Does the fact that they're 2 years apart have anything to do with this problem? Does it matter what the age is? No, it doesn't matter. So I don't need this. This is real world, guys. In the real world, you're going to have lots of information and data that you don't need. Okay, so that has nothing to do with the problem. So basically what they're asking is, what are the chances that I get girl, girl, girl? Okay, so what is the probability that the first child is a girl? I'll give you a hint. It's 1 out of 2. It's either a boy or a girl. Okay. What are the chances that the probability that the second is a girl? I'll give you a hint. It's 1 out of 2. What's the probability that the third is a girl? I'll give you a hint. It's 1 out of 2. Okay. So this is just the same thing as flipping a coin. Heads or tails. Don't have a boy or a girl. Okay. But let's look at the trigger words. What is the probability that the family has 3 girls? Whoa. I don't see replace. I don't see without replace. I don't see and. I don't see or. I don't see jack squat. Okay. The words are embedded in there, guys. They're in there. You got to think about it, okay? So what are the chances? Think about it. Read the problem out loud to yourself or in your head as you're taking the quiz. What are the chances that I get a girl and then another girl and then another girl? So the and is in there, okay? So if you don't see the words, then think about it. Is it an or is it an and? Okay, this is an and. So what do I do with the probabilities? I multiply them together. So 1/2 times 1/2 times 1/2. Now, of course, you can rewrite that as 1/2 cubed. So on your calculator, you need to put that in parentheses, okay? 1 divided by 2, raise that to the 3rd power, okay? And we get 0.125. Let's convert that to a fraction. Math, enter, enter, boom, boom, and there's the fraction. Okay, so that's going to equal 1/8. Okay. All right, let's move along. Okay. All right, flip on over to the back. Whew, this is a doozy. I'll go ahead and tell you guys right now, you're not going to have a problem this complicated on the quiz, but this is a good problem. It says a local donut shop is having a free donut day. Because the store is busy, they decide to speed up the service by telling people that they have to take what they're given. That means that people get a free donut, but they don't get to choose which kind. So that people just come in here, boom, boom, here's a donut, here's a donut, here's a donut. Get what you get. There are 4 different kinds of donuts, so let's just assume that we have vanilla, chocolate, strawberry, and lemon. Okay, 4 different kinds of donuts, equal amounts of each kind in the box to choose from. So maybe there are 100 donuts. There are 25 vanilla, 25 chocolate, 25 strawberry, 25 lemon. Okay, maybe there are only 12 donuts in the box. I don't know. It says, what is the likelihood that the next 3 people will get the same donut? Okay, do you see replace, without replace, and or? I don't see any of that in here. Okay, but it's in there. The and is in there. What are the chances that we get 3 vanillas in a row? I get vanilla and vanilla and vanilla. Okay, so the and is in there. Okay, so that tells me that I'm going to multiply my probabilities. It's not or, it's not you get vanilla or chocolate. I'm getting 3 in a row. Okay, and remember, guys, the difference between and or When you see the word and, we're doing multiple things. I'm pulling multiple cards out of the deck. I'm drawing a king, and then a queen, and then a 2. I'm getting a girl, and then a boy, and then a girl. Okay. When you see the word or, you're only pulling one thing. I'm pulling a card. I get a king or a jack. Okay. I'm going to go into the store. I'm buying a dog or a cat. I'm only doing one thing. Okay. So keep that in mind. If there's multiple things going on, we're going to be multiplying our probabilities. Okay. So what is the likelihood that, what are we doing on the first person though? That's what makes this problem hard. What do I write down for the first thing? It doesn't matter, guys, what donut they pick or what donut they get. Okay, 100% of the time, the first person is going to get a vanilla, a chocolate, a strawberry, or a lemon. Okay, they're going to get a donut. And since there are 4 different kinds, I'm going to say the probability that they get one of those is 4 out of 4. There's not a 1 out of 4 chance that they get one of these. There's a 4 out of 4 chance that they will get a donut. We don't care which one it is. Okay, and then after that, let's assume the first one gets a strawberry. Okay, they're guaranteed to get something. After that, the chances of them getting another strawberry is going to be 1 out of 4. Okay, and then the chances of the next person getting another strawberry is also a 1 out of 4. Okay, so students get confused. What is this 4 out of 4 stuff? This could be a million out of a million or 1 out of 1. 100% of the time, they're going to get a donut. We don't care what kind. And then after that, you got a 25% chance of getting the same one. Okay, 4 out of 4 is just 1. 1 out of 4 times 1 out of 4 is 1 out of 16. Okay. All right. So hopefully that's clear as mud. I know that was kind of, you got to think about that a little bit. All right. So let's move along. Okay. You roll a pair of dice. Okay. So let me get out my dice here. Let's go red and blue. I have a big old thing, a jar, big old jar of dice. All right, we got red and blue. 2 dice. 1 die, 2 dice. What is the probability of rolling a sum of 7? Okay, let's focus on the red die. And let's look at all the different combinations. Okay, let's say we roll a 1 on the red. How would we get a 7? That's got to be a 6 on the blue. Okay, so one combination is a 1 and a 6. Okay, let's keep going. If I roll a 2 on the red to get a 7, that would have to be a 5 on the blue. So that would be 2 and a 5. If I roll a 3 on the red, that would have to be a 4 on the blue. So I'd say 3 and 4. If I roll a 4 on the red, that would have to be a 3 on the blue. So then I would say a 4 and a 3. And yes, those are 2 different things, as you just saw. I can roll a 3 and a 4, red, blue, or I can roll a 4 and a 3. Okay, blue, red. Okay, so then let's keep going. So if I roll a 5 on the red, that would have to be a 2 on the blue. And then, of course, if I roll a 6 on the red, that would have to be a 1 on the blue. So it would be 6 and 1. So those are all the different combinations. Okay, and I have 6 combinations. 1, 2, 3, 4, 5, 6, because I have 6 numbers on the red one. All right, so what is the probability that I'm going to roll a sum of 7? Okay, well, we see 6 different combinations. It's going to be 6 out of something. Well, how many different combinations can I have on 2 dice? Okay, well, you got to think back to our principal counting rule, where we said, okay, I've got 4 ties, 3 slacks, and 6 shirts. How many different combinations? Okay, let's do this up here. I got 4 ties, 3 slacks, and 6 shirts. How do I figure out the combinations? What do we do with these numbers? We multiplied, right? 4 times 3 times 6. That gives me the total number of options. Well, here I only have 2 options. I've got 6 numbers on the red. I've got 6 numbers on the blue. So our counting principle says to figure out the number of combinations, what do I do with those 2 numbers? I multiply them together. 6 times 6 is 36. Okay, 36 different combinations of rolling a blue and a red die. Okay, 36 different ways. Now I need to simplify that. So again, punch in your calculator if you're not strong with math numbers. 6 divided by 36. Okay, math, fraction, boom, boom, 1/6. Okay, you have a standard deck of 52 playing cards, and you pull a card out at random. What is the probability that you pull a heart or circle that word, guys. I'm going to grab my deck of cards over here so I can give you guys another illustration on the video. Okay, a heart or a jack. Okay. Also, if you guys need to, let me grab that strip of paper real quick. Also, you guys, the strip for the deck of cards that I passed out, you guys will be able to use this on the quiz and the test if you're not familiar with cards. Okay, so I see the word or, guys. I see or. Okay, so that tells me I'm going to do what? I'm going to add my probabilities together. And then it's a matter of whether or not it's exclusive or inclusive. Am I double counting? Can something happen at the same time or not? Okay, all right, so what's the probability that I get a heart? How many hearts are in the deck? Okay, well, here are my hearts. I have 13 of every suit. 13 clubs, 13 diamonds, 13 hearts, etc. Okay, so the chance of getting a heart is going to be 13 out of 52. Okay, or 1 out of 4. But I would encourage you guys to leave this denominator. Don't simplify until you get to the very end, because it's easier just to kind of add the common denominators. Okay, what are the chances of getting a jack? How many jacks are there? 1, 2, 3, 4. There's one card in every suit, so there are 4 jacks. So I'm going to add the 4 over the 52. Okay, but then you got to stop. Is this mutually exclusive or is this inclusive? Can I be a heart and a jack at the same time? And the answer to that is yes. I've got the jack of hearts. It's both a heart and a jack at the same time. So what I have to do is I have to subtract out that overlap. There's one card in the deck that is both heart and jack at the same time. Okay, and the reason for that is I did this demonstration class, but I'll do this again for those of you who I might not teach that are watching this video. So the reason why we have to subtract out the 1 out of 32 is so you don't double count. Okay, so we said there's 13 hearts. Okay, so let me zoom out while I do this demonstration. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so there are my 13 hearts. Okay, and then I want to find, we're saying that there are 4 jacks in the deck. Okay, there are my 13 hearts, so let me go find the 4 jacks. 1 jack, 2 jacks, 3 jacks. Whoa, wait a minute. I don't have any other jacks in the deck. I thought it was 13 and 4. Okay, so what happens is, the reason why we have to subtract out the 1 is because we got this jack of hearts over here. I can't count the jack of hearts in the hearts and in the jacks. I'm counting it twice because it's a jack of hearts at the same time. Okay, so that's why we have to subtract out the 1 out of 52s, because consider this. If you don't subtract out the 1 out of 52, if you don't subtract out the overlap, you would say your final answer is 13 plus 4. You would say the final answer is 17 over 52. But I don't have 17 cards here. I have 3 jacks and I have 13 hearts. Okay, that's only 16 because if I don't subtract it out, I'm counting that jack twice. I really hope you guys understand that. That's the whole deal with mutually exclusive. You don't want to, or excuse me, inclusive. You don't want to double count. So I'm subtracting out, I'll put in parentheses, I'm subtracting out the jack of hearts. Okay, so let me zoom back in. Alright, so now when you have a common denominator, guys, all you do is just add or subtract across the top. 13 plus 4 is 17 minus 1 is 16 out of 52. Okay, if you do have common denominators, please just type it in on your fraction. Okay, you don't need to put anything in parentheses. 13 divided by 52. 13 divided by 52 plus 4 divided by 52 minus 1 divided by 52. Math, fraction, and that's the 4 out of 13. Okay, so 16 out of 52 reduces to 4 out of 13. So let the calculator simplify your fractions for you. Okay, an inspector selects a sample of 212 auto parts and finds that 8 are defective. Estimate the total of defective parts if the company has 1,450 parts in stock. Okay, so first thing we need to do is say, okay, there are 8 out of 212, 8 bad parts out of 212. Okay, well, what do I do with this 1,450 number? Consider this. Let's say we shoot 100 free throws in basketball, and let's say we make 50 of them. Okay, That's 50%, right? You made 1 out of 2. Okay, so if I want to know, based on 50%, how many free throws would I make out of 600? Okay, or the other way to think about it is if I shoot 600, how many am I going to make? Well, if it's 50%, don't you just take 50% times 600? Wouldn't I just do 0.5 times 600? And that would give me 300? Because 300 over 600 is the same thing as 50 over 100, right? So we're going to take that same concept here, except this is not 50%. You don't have to do this, but I'm just showing you for illustration purposes. 8 divided by 212, that's a decimal, times 100%. That means this inspector is finding a bad part about 3.8% of the time. So just like in basketball, we took 50% times 600 to give us the number of free throws we'll make. I'm going to take this 3.8%, or 8 over 212, and I'm going to multiply that times the number of free throws that I'm shooting, or the number of parts that we have in stock. So I'm just going to multiply it times the 1450. Okay, so 8 divided by 212 times 1450, and that gives me 54.7. Okay, so that's the percentage. All right, so I'm just gonna round that. I'm gonna say that's roughly, a little squiggly, that's roughly 55%. Okay. Oh, excuse me. I'm sorry, guys. This is asking what is the total number of defective parts. I'm sorry. I apologize. I almost caught myself there. It's 55 total parts. That's not a percentage. Excuse me. Okay. So just like we said, we make 300 free throws. I'm going to have 55 bad parts. Okay. All right. So now we're putting letters in a bag. What is the probability of pulling the letter A and then without replacement? So I don't put it back. Okay. What is the probability of pulling A without replacement and then pulling a vowel? Okay. All right. So when I see without replacement, I don't see the word and. Most of the time you'll see it right here. It will say it right here. It will say and then without replacement. But if you see replace or without replacement, then we're back to our graphic organizer, right? With replacement or without replacement. That's under the and. All right, so I'm going to multiply my probabilities together. All right, so the chance of pulling A the first time, I have 1, 2, 3, 4, 5, 6, 7, 8 different letters. How many A's do I have? I have 2 A's. I have an A here and an A here. So the chance of getting an A the first time is 2 out of 8. Okay. All right, now I'm going to multiply that. Now, if we say without replacement, one of these A's, I'm going to keep it outside the bag. Okay, I don't put it back in there. So the chance of getting another A, there's only one, or the chance of pulling a vowel. There were 3 vowels. I had an A and an I and an A, but since I pulled that A out and don't put it back, I only have 2 vowels left. I have the A and I have the I. Okay, so the second draw, I only have 2 vowels, and I don't have 8 letters in the bag anymore because the A came out of the bag. So I only have 7 letters left in the bag. Okay, does that make sense? All right, so I multiply those together. My calculator, that comes out to be 404 over 56. Let your calculator do the work. That comes out to be 1 out of 14. Okay, Venn diagram. All right, so use the Venn diagram below to answer the following questions. All right, so LA. That means give me everything in LA. I'm not going to circle all this stuff. Give me everything that's in the circle LA. That's going to be Devontae, Heather, Jessica, Chris, Betsy. All right, give me the overlap of math and science. That's the intersection. So give me the overlap of math and science. What's in both circles? That's going to be Ashley and Eder and Chris. Ashley, Eder, Chris. Sorry, I couldn't see that. Ashley, Eder, Chris. Okay. Intersection. I want the overlap of math and not A. Okay, so I'm going to do these with Christmas colors, green and red. Okay, give me the overlap of math. Okay, I'm circle everything in math in green. Okay, those are all the maths in green. And then I want not LA. That tick means not. So in red, I'm going to circle everything that's not in LA. George is not in LA. Ashley and Eder, Isabel and Krista are not in LA. Okay, everything else is in LA. Oh, sorry, Frank. Frank's not in LA either. Okay. I want the intersection. I want the overlap. So in other words, where did I circle green and red at the same time? Isabel and Krista, and Ashley and Eater. That's what the overlap means. Where did you see? And bring colored pencils to the quiz tomorrow, guys. All right, so the intersection is going to be Isabel, Krista, Ashley, and Eater. Isabel, Krista, Ashley, and Eater. Okay, Math Union LA. The right side up U means give me everything. Give me everything that's in LA. Everything that's in LA. That's Devontae, Chris, Heather, Jessica, Betsy. And also give me everything that's in math. Okay, we got Isabella, Krista, Ashley, and Eater. Okay, so we've accounted for everybody that's in the math circle and everybody that's in the LA circle. Union, together. Give it all to me. Okay, so let y'all make sure y'all have that copy down there. Okay, I want the upside down U means intersection. I want the overlap of math and LA and science. So where do all three circles overlap? Right there in the middle. That's just going to be Chris. Okay. Alright, so I might have to break this video up into two parts, guys. Belle's going to catch me here in just a few minutes. Let's see if I can get through a couple more here. What is the probability of flipping 3 coins and having exactly two of them land on tails? Okay, this is exactly like the problem that we had from the homework from night 1, where it said, instead it just had heads. It said, what is the probability of having exactly the coin landing on exactly two tails? Okay, so if I were to list out, I'm not going to do the whole tree diagram again. You guys can just look back at the posted solutions for the homework from night 1. But if I were to list out all the combinations, again, I got HHH, HHT, HTH, HTT, THH, THT, TTH, and TTT. Okay, those are all of our 8 combinations. So which one of these combinations has exactly 2 T's? No, 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 yes, no, no, yes, yes. Okay, so 3 out of the 8 paths give me exactly 2 T's. At a local ice cream shop, there are 2 choices for a cone and 9 types of ice cream in 3 different sizes. How many ice cream options, choices, options? This is our fundamental counting rule. All I do is I just multiply all the numbers together. 2 times 9 times 3, and that gives me 54 different options. That's super easy. Please don't miss that one on the quiz. Just multiply the numbers together. Okay. A bag has 4 red, 2 green, 5 blue, 4 yellow pieces of candy. What's the probability of picking a blue, replacing it, and? So this one, they were nice to us. They gave us both important trigger words, replacing, and they gave me the word and. So I see and, I'm going to multiply. All right, I put it back. So that means my denominator is going to be decreasing by 1 every time. Okay, so I want to put, first thing I want to do is pick a blue piece. All right, so what are the chances of drawing a blue piece? All right, I have 5 blue out of a total of 4 plus 2 plus 5 plus 4. That's out of a total of 15 pieces. Okay. And, oh, I'm sorry, I misread this. This says replacing. Okay, I misread that as not replacing. Replacing. I am going to put, I'm drawing a blue piece, drawing a blue piece out of the jar, and I'm putting the blue piece back. Okay, so when you put it back, the denominator does not change. So the chances of picking a green one on the second one is 2 greens, and I still have 15 pieces of candy in the bag because I put it back. Okay, so the denominator does not change. So when you multiply those together, for sake of time, I'm not going to do all that in the calculator. That comes out to be, the final fraction is 2/45. Okay, and I think I'm going to need to stop there, guys, because the bell's about to ring. So I got 15 through 20, so I'll just do that in a separate part, maybe during lunch. So that's it for this video, and hope you guys enjoyed it. Hope this helps you out, and look forward to seeing you on part 2 of this video.